you want me to just jump in?
Yes.
Okay.
Feel free.
Sure. So, good morning, good afternoon, good evening. I think most of you actually, depending on where you are on the globe. Thanks for having me here in this community session. It's always good to talk to our dear users out there and people that make the time in their evenings to think about our product and our strategy and our products as Microsoft. So it's great to see so many of you here. So thanks for making the time, and thanks for listening to me ramble on this as well. So just as a quick intro of myself, let's see if that actually works, that clicker thingy. There we go. You might go like, hey, wait, I know that guy. And if you follow Power BI closely, you might see my ugly mug on the monthly blog update. So whenever Power BI releases a new version, we do that every month. We blog about it. We tell you everything that we changed and the new features that we built. And I have the honor to build that and to share that out to the world. So that's where you might have seen me. I also see somebody in the chat already that they're totally new to Power BI. Welcome, first of all, of course. I will assume you know kind of a little bit of things around Power BI. So I won't start from like level 0, but let me know if I need to explain some concepts if I jump over them too quickly. So basically, I'm a program manager on the Power BI team. It basically means that I'm one of the people that make decisions on the future of the product. So you have like for Power BI Desktop, you have like 5 of us now. I'm one of those, and I focus on modeling and DAX. So everything that has to do with like how do I actually build the data model that allows me to create visualizations in Power BI in my report. That data model and how you build that is my area. DAX is our programming language, which is how you build calculations in Power BI. It looks a lot like Excel formulas, but then once you start diving deeper into it, you notice it's absolutely not like Excel formulas. It's way more powerful, but also a little bit more complicated. So that both of those I basically own, and I make decisions on what the future of these things should be and what the features are that we want to build. I don't build code myself. I don't write code myself. You wouldn't trust me doing that. We have brilliant software engineers that actually write the code that you use as part of the product. So they make the product, they build the code, they write the code that builds the product. I'm just here to make sure that we build the right features and that we have a good idea of where we're going and why we're going that way and what the features are that we're going to ship. And then I get the opportunity to talk about those features. So basically, I'm all the way at the beginning of the process of building a feature. Then the development actually happens. Then I'm getting back into it with testing, making sure everything is okay, and then shipping it basically means talking about it publicly, like in community sessions or on the blog or on YouTube or whatever. So that's kind of my job. I've been with Microsoft for almost 15 years. I am originally from the Netherlands. That's why I'm also called the Dutch Data Dude. That's my nickname. And I moved here in December 2018 to the US to join the product group. Because Microsoft has, of course, their headquarters here in Redmond, Washington of the US. So that's where our development really is focused. So if you want to keep in touch or want to follow me on any of the social channels, feel free. There's also my email address if you have any follow-up questions. Always happy to help and chat. So for today, what I wanted to cover is composite models, and specifically an update to composite models that we have done for Power BI a little while ago that is still in preview. And that preview is still ongoing, and I'll talk about what composite models are in just a second. And then we'll talk about some more best practices and special considerations that we've learned from users using our new composite models, our improved composite models in our preview. So that's basically the meat of the session. Will be like, okay, once we understand what composite models are about, how should you actually be using them and how should you not be using them? And that's sometimes even more important than just knowing how to use them. By the way, if you have any questions at any point, please feel free to use the chat. I'll monitor it. Also, there is a raise your hand functionality in Teams. I would encourage you to use it so I can ask you to unmute. Otherwise, please stay on mute. So that's basically the plan. Okay, sounds good. Let's keep going. So composite models. When we say composite model, really you should think about what a composite is. And a composite is almost like you have those glues, like those industrial glues that you can use to glue things together in a really strong bond that you can buy in like a big box store or whatever, or do-it-yourself store. That's a composite glue because what happens, you get two tubes and you combine them together to make a composite. And that's only when the glue actually activates, becomes sticky, and starts gluing things together. The two components separately don't do anything. And that is basically also what a composite model is. So think about Power BI as, hey, it's a tool to make data visualizations in and analysis and reports. Great. It can connect to data, but the beauty of it is that you can actually make a composite out of one or more than one data source. So you can say, hey, I've got my business data warehouse that we connect to, which is like our standard data warehouse that everybody uses. And then I have this Excel sheet somewhere, or I have a source from the internet that I want to pull in. And then when you combine all of those, you mash them up, as we say, to a composite model. You take data from the data warehouse, you take data from your Excel sheet, you take data from the website, the public website, and together that creates more value than you originally had when you just were looking at your data warehouse. So essentially, when we say composite model, what we say is you're connecting to more than one data source and bringing those together into a model that actually allows you to do interesting analysis. Let's take an example. Let's say you work for an international company that sells products worldwide. You have a database from IT that tells you exactly which product we sold when, in which country. Probably to a customer, but that's not important right now, right? Which product did we sell on which date in which country? Great. If you wanted to do, for example, what's our market share in percentage of number of people living in that country, right? So chances are you cannot answer that question from your IT database because chances are that IT doesn't really track the number of people living in the country, right? They probably don't have that list in that database. However, if that's your business question, like if there's like 50 million people in the country or 10 million people in the country, the number of products that we sell is percentually different. So what if you could just say, hey, I've got that data about our sales in various countries, and then we go to the web, and then somewhere like the World Health Organization, for example, tracks the number of people that live in a country. Right, so we track that and we add it into Power BI, and then we relate it on the country because the country is here for the number of people and the country is here for the number of sales. We relate those together. So now we have two sources that are combined together that bring more value because now I can do the calculation of percentage of, capita that we sold a product to in this country. That's a composite because it adds more value. It brings more than one source together. And by doing that, it brings answers to insights that you were never able to do before. That's a composite model. Very simple. Now that is existing functionality. You might sit here and go like, yeah, I know that, right? Power BI did already have composite models. Yes, we did. You could have done that a couple of years ago already. That's not new. However, what is new is that you weren't able to do composite models on all most popular data sources. And there were a couple of data sources that you couldn't use composites on. And that particularly is SQL Server Analysis Services or Azure Analysis Services, to be more specific. The analysis services model that lives in Azure, which is the Cube technology in Azure, and Power BI Datasets. Power BI Datasets are the things that you get when you publish Power BI reports from the desktop into our cloud version. You get data sets. And once you connect it to either of those sources, so an Azure Analysis Services source or a Power BI data set, you weren't able to add any other source. So you weren't able to create a composite. So when you build a report on those sources, the only thing you could do is look at the data in that source. You couldn't still add other data to it. Now, since this preview that started in December 2020, we have that capability. You can now build a composite on top of an Azure Analysis Services source and a Power BI dataset, which is a great new capability because those are the, outside of SQL Server, the two most popular sources for Power BI. So the fact that we have this now is exciting. It is still in preview. We're still running the preview because this is a very big feature with loads of impact across the board. We're still learning, we're still building this, so we haven't really made this generally available yet, but it is in public preview. You can use it. However, don't assume this is a production version right now because it is not built for production. So, but during the preview, we've learned a lot about what customers do, how to use it, what the challenges are, and how to best use this. So that's what I wanted to cover in this session. But before we do that, let's just look at a quick demo of what this does. Hopefully that also helps if you're new to Power BI. So let me switch to the Power BI desktop here. There we go. Sorry, wrong window. Oops. So here we go. Here we are in Power BI Desktop. I have desktop loaded, nothing special. The only thing I have in here is one source. On the right here, you can see my sources, and I see that I have, or the tables that are loaded from the sources. And here I have one source connected to, and there's one table. It's a table of reseller groups. This is an original Excel file. So this is data that I got from Excel. I imported this into Power BI. So I went here, get data, or to this button to get to the Excel workbook, and I told Power BI to load this data. So I can now see this data here. I have a list of reseller groups. That's nothing very special, but it is there. Now, great. This is not a composite because there's no two data sources or more than one data source in this report. But now what I can do is I can connect to a Power BI dataset. So when I do that, I will actually now connect to a pre-published report that somebody else built. Presumably, of course, for this demo, I built it, but presumably it's somebody else's report that I connect to that shows me kind of what I wanted to know, but then is probably missing some information. For example, it's information about our resellers, but that grouping that I have in Excel is missing from that report. So what I'm going to do is I'm going to take the data from the report, that data set, and then I'm going to add my reseller group onto it. So now let me just first connect to that source. That is this one. So I'm going to create a link to it, so connection to it. It will probably tell me that, hey, the fact that you're bringing this together will require a local model and may have security warnings. So we'll see what happens. But because of the security warnings, we will have to tell you that data might be shared across depending on how you use this. But before we get to that, I have the opportunity to choose what I want to import from this data model, from this data set. Previously, you weren't able to do this, but now I can specify either using like a perspective to select the tables that I wanted, or just regular the database, and I can just go in and say, you know what, I'm only interested in these tables. I don't need sales order. I'm only interested in these tables from that source. So I don't want to do everything. I also have a magic checkbox here at the bottom to say include any tables that get added later. So imagine this dataset gets published, re-updated after I connected. Do I want any new tables to show up in my data source automatically, or do I not want that and I need to go in to add them later? For now, I can just say add later whenever that happens. Sales order will never be there because I deselected it. So those are the tables that I'm going to connect to in the data source. So when I click submit, I might have to authenticate because that's what I have multiple testing accounts, so that's why that is happening. Of course, whenever you do a live demo, it never works. That's always great. Let's take a look on why that is not happening. Demo gods work with me today. Come on. Let's see, it's enabled. That's weird. Let me try that again. Maybe it's just a temporary issue. Because it wasn't able to connect, which is interesting. Yep. Okay, doing it again. Okay, now I'm gonna go sales order deselect. Whoops. Submit. What the heck? What's going on? Why doesn't it work? Okay, that's great. That's awesome. Great demo. Nice. Okay, I'm gonna try another source, see if that will work, but I don't think it will work. And that's too bad. It's really bad. Okay, let me try that. Well, at least you can see now that the demo is real and it has not been pre-recorded. So let's see. Nope. I think there's an outage on our internal systems, because otherwise this would have worked. I am with the right account and try to just reboot Power BI, but I don't think that will change anything. Just do that real quick, but I don't think that will change. Okay, so I'm going to restart Power BI once and try it once more. If that doesn't work, then I'll just continue. But basically what I was trying to do, so I was trying to show you how that basically you can map up any other data, match up any data together, and then even across those data sets, create relationships so you can actually build like a real composite that relates, for example, that reseller group versus the resellers that I had in my database. And I can even create measures across that. So I can even say, for example, in these example that I have here, right? If I have a reseller group and I have sales per reseller, I maybe wanted to do, let's say, an average of sales per reseller group, which is not something I can calculate without those two sources or without a relationship between the two sources. Because if I don't have reseller group in my original source, I only have reseller and sales amount. I don't have both. So if I relate them together and add a measure, I can then do that average calculation, right? So that's what I was planning to show you, but I can just talk to it. I will do it one more and just try to see if that will magically now work. If not, we'll continue. So just selecting the guy again, seeing that work, fingers crossed. Getting the login prompt, which is also really weird because I was already connected. So this is worrying. Yeah, okay. I'm gonna call it quits for the demo for today. I'm so sorry about that. Nothing I can do. But basically what I was trying to do is show you that you can now build a composite based on Power BI data sets and connect them together, build calculations, build measures, which are DAX calculations on top of it, to do, for example, average per reseller group, which is not something you could have done without combining those two sources. Great. So when we designed this feature, there was a couple of things that we had in mind. And it's good to talk about that because we've seen people use this kind of capability to combine multiple data sources and data sets together and make a composite model on top of it for many different scenarios. And not all of them were actually what we had in mind when we designed it. So let's talk about that. So the goal of this feature was to allow you to add data to an enterprise semantic model. So when we say enterprise semantic model, I'm talking about an Azure Network Services source or a Power BI data set. We basically had in mind that we would allow you to add data to it. For example, the scenario that I was trying to show you, like reseller group is not in the data set. I wanted to add reseller group because it adds value to my analysis. That's what we had in mind. We call that extend. The other scenario we had in mind was enrich. Basically, you're not trying to add more data, but there's a calculation that you would really like to see that is not in the original source. By adding a measure or a calculated column or a change in formatting, that's a great one. For example, if you have customers all across the world, you might be consuming a data set that was created by somebody in the US. And in the US, they tend to write the date as month, day, year. But for example, in Europe, where I'm from, we write the date as day, month, year, right? The day of the month and then the year, not the month and then the day and then the year. So if somebody from the US creates a data set, they probably will format the date as month, day, year. But if your consumers of the data set, your customers, the ones that need to look at it, are in Europe, that might trip them up the first couple times. So why not allow you to enrich it to say, I'll publish a special version of this data set for you that you can just change I change the format string for you so it makes sense to what you're used to. And that way it's easier for you to consume it. Now, that's not a copy of that data set. The same data will still be there in both data sets. It's just a pointer or a viewpoint towards the original data set, right? So you're not creating a copy. You're just saying, hey, the original is there. Whenever that gets updated, I'll also get the latest version, but then I'll enrich it with like a different calculation or a different format. And I'll tell you to use that one because that makes more sense for your scenario. The other scenario we had in mind was overview, basically saying, let's create a dashboard of multiple data sources, not relating them at all, just single pane of glass, seeing multiple data sets side by side so I can get a complete cockpit overview of my data in my business. It's important to note the disjointed here. Basically, it says no relationships between those two sources, and I'll explain you why, or multiple sources. The non-goals, so the goals that we didn't have in mind were combining two or more large semantic models, so large Power BI datasets or Azure analysis sources, by joining them together. That was not what we had in mind. We have seen people use it successfully as well, but that was originally not our design goal. The same for combining a large dimension table and a large fact table from different sources. So let's say you have a large sales table in one source and a large customer table in the other source, and then relating those two together was not our original intent of what this feature would do. It does do it, but it was not designed for it. And the reason I tell you this is because, as you might know, you run into some trouble when you start doing this using this feature. So some definitions that I'll use in the best practices, we'll talk about cardinality, which basically means the number of unique values in a column. Enterprise semantic model is what I said, a centrally managed Power BI dataset or an Azure analysis services. And then when you look in our documentation, you come across a couple terms. So source group is everything loaded from one DirectQuery source. So when we connect to Power BI datasets, you get a DirectQuery connection. That's a source group. And then everything you imported, so everything you connected to from, let's say, a file like a CSV or Excel, is all in one other source group, which is import. So you might very well end up with multiple source groups, one per DirectQuery source, and then one for all of the imports together. And then when you create a relationship between tables that are in different source groups, we call that a cross-source group relationship. And then we also have the concept of a remote model, which is basically that model that sits in the service that you point to, that you created an enrichment to or added data to. And then you have a remote versus local table. Basically, a remote table is everything that's in the source, and a local table is everything that you have local. It's very simple. That's just basically the difference. And it's important to note this because that's where the best practice we'll talk about. And then we have one more definition, which is wholesale versus non-wholesale. And this is not a very simple concept, but basically, think about it as follows. Whenever a calculation needs to happen inside of Power BI, it gets executed in a query or it gets executed in a measure. If that calculation can be executed by just looking at one source group, so data from either the import or from one of your connected sources like a Power BI dataset, then we call it wholesale. If it requires references to more than one source group, we call it non-wholesale. So for example, if customers is in one source group and sales is in the other source group, and I'm trying to say, what was the average sales of this customer for this year, for all the orders that they had? That is a measure that is non-wholesaleable because it requires information from customer and from sales, which are in two different source groups. If customer was in the same source group, that measure would have been wholesaleable because it's in one source group. It's important to note that distinction because it has very important performance implications. Okay, so once that's out of the way, let's look at best practices. The first one is you should really avoid combining multiple enterprise semantic models. Although this feature doesn't stop you from doing this, you can technically do this. We've seen people be successful with it, but we've also seen people being burned by horrible performance because of this. Keep in mind, this feature wasn't built originally to allow you to do this. This was not what we had in mind when we designed it. So instead of combining multiple data sources, like multiple large data sources, and trying to wrestle all of the tables into Power BI and keeping two big data sources side by side, that's not what we designed this for. We envisioned you to go load one bigger data source and then add maybe a couple more smaller satellite sources to it, which means you could either just take tables from a bigger data source as a second source, but don't try to connect like multiple big data sources, like large ones, with multiple tables side by side and even overlay 3 or 4 or 5. You will shoot yourself in the foot really quickly. That's not what it was built. Instead, think about what adds a meaningful enrichment to the original data source that you had and add that. That is what we had in mind when we designed this feature. Again, the feature doesn't stop you from doing this, but you shouldn't be doing that. Then when you create a cross-source group relationship, so when you create a relationship across two sources that you connected to, think about what we call the cardinality. So that relationship has a key column. It has customer key on both sides, so you can relate those two sources together. The cardinality of those key columns should ideally be what we call small, and small would be approximately 5,000 unique values or less. So if, 50,000 unique values or less. So if you have 50,000 unique customers in your customer table, you can successfully create that relationship to relate it to the sales table on the other source, but keep it around that number. If you have 500,000 customers on the other table related to the other source in sales, you are violating this best practice and you might see performance issues. So we will tell you, try to group customers together or not relate on individual customers between the fact on the one side and the other side to reduce the cardinality. So cardinality, the unique values should be less than ideally than 50,000. This one is a doozy if you ever worked with Power BI before, but it's something that I have to repeat, is use a dimensional model. Don't try to use a spaghetti model or a single table model. That is not what Power BI likes. That's not how Power BI was built. That's not what we assume when you work with Power BI. We assume you have a dimensional model, which is also called a star or a snowflake schema. A star schema or a snowflake schema are both types of dimensional models. We assume you have that. We assume you use it. Of course, it will work fine with small data sets that don't have a dimensional model, and small is like less than a couple 100,000 rows or a couple million rows. It will work fine. You probably don't have any issues. However, the moment you work with larger data sets, you will want to have a dimensional model. Also, the moment you try to do DAX calculations, so any calculation that uses a DAX programming language in Power BI, it makes assumptions about your model to optimize and to provide loads of performance. And it makes those assumptions under the idea that you have a dimensional model. If you have anything else, you might get weird results. So use a dimensional model. It's especially important when using this feature, but in general, when you use Power BI, use a dimensional model. And then if you can, try to rethink where you put your tables. So when you combine data sources together, ideally, you want to keep all the dimensions and the facts, so all the numerical values and the context information. So facts are numerical, dimensions are context information. You want to keep those together in the one source. So try to limit those large cross-source group relationships where you have a large fact table in one source, presumably your sales with multi-million rows or billion rows, and then you have a customer table on the other side and you try to relate those together. You should really ask them the moment you do that and build that across source groups, so across two sources in this kind of fashion, you should really think about, like, should that customer table really be in a separate source? Could it not just be in the other source, and could it not just move it there or ask somebody to move it there? Because then the relationship will be way more performant and work way better than when it is cross-source group. Because when it is cross-source group, we cannot do optimization. So we cannot optimize the performance for you. So whenever you see this happen, when you have large relationships with the cardinality of 50,000 or up, think about trying to keep those things together into one source. Okay. Then when you're building calculated columns, so calculated columns is a way to add basically calculations to a table in Power BI. So you can do like, it's much like Excel. Like if you have an Excel sheet, you can add in a new column, you can add a calculation that says, hey, get data from column A and B and multiply them, and that's the result for column C, right? That's a calculated column. Again, this feature allows you to do that. But you should keep them simple. So try to avoid creating calculated columns that are very complicated across large tables. So what we mean is especially important when you work with a virtual table, so basically a remote table. So if your sales table is in the remote source and you're trying to add a calculated column in your composite, you can definitely do it. However, keep it simple. And also rethink your strategy. Should that calculated column really be part of that source? Because if you can move it into that source, that's a better approach than keeping it to your local model and just building it on the remote source. So basically the left one is the remote, where the table A is in the remote model, and I create a calculated column in my local composite that I just built. That might work fine, but if that calculated column is complex enough, the performance will suffer. You should really think about, can that calculated column not just be part of that source and from the beginning, so I don't have to redefine it locally? If you can, move it there, because it will be better performance for you. And then when it comes to creating visuals, of course, Power BI can create any visual, can create like, all kinds of charts. Great, it's awesome. And the beauty of it is that you can combine data from multiple sources. But the fact that if you do that, you will potentially open yourself up to some performance issues. So if you can, try to limit the columns that you show in one visual to one source. Don't try to put columns from two visuals or more than one visual in one source. Sometimes you have to. That's just your use case. It's fine. It will work. But try to avoid it, because your performance will be way better if you split out those visuals. So here in the example, we have two sources, the blue source, which provides product table and a sales table. And then we have a cost numerical value that comes from the yellow source. Now, I added both of those. I built a relationship between them. Fine. I can show them in a visual. That's what I did on the left. That visual, however, will be less performant. So we'll have less performance than if I did the same, but then split into two visuals, where I just repeat the product column from the blue source and the yellow source. If I do that, assuming that the relationship is on product, I could actually get better performance having these two visuals side by side, still providing the same result, still providing the same insight, than having them in one visual. And of course, this is a very simple example where I only have one column duplicated. But try to avoid that situation if you can. I know that you cannot always avoid the situation. Sometimes you have to do this across visuals, across source in one visual. So you have more than one source in a visual. It's okay, it will work. But if you worry about performance, if you run into performance issues, this is one to look out for. Like, can I actually maybe do something else to just create two small visuals that answer the same question? Because again, if a query gets executed and on a visual, so let's say the right visual, the yellow one with product and cost gets executed, we execute that query to the source. Since it only needs data from that one source, it's wholesalable. So it means it can be optimized. So the performance will be better than if you have the query from the left, which is by default, by definition, because it requires data from more than one source, non-wholesalable, so non-optimizable, so your performance will be better, will be worse than when you do the first one, the other one. Okay, so special considerations. These are not best practices. It's just something to keep an open mind to and be aware of. This will become pretty technical really fast. So if you're new to Power BI, just bear with me. You don't have to keep this in mind all the time when you work with Power BI, by the way. when you use Excel on top of this feature, you have to be a little bit careful. So when I say use Excel on top of the feature, what I mean is what you could do is you could build a composite model that connects to that Azure data source or that Power BI data set and adds that Excel sheet and publish that back to the service. And then you could tell to your colleagues, hey, just go in Excel and then connect to that data source and do your pivot tables or pivot charts from Excel, getting the data from the data source. It's a perfectly fine scenario. Right? It's just, we call it analyze in Excel. You can find it in the service. You go into the desktop, you can a data set, you can go analyze in Excel. We'll open Excel for you, build that connection. You can build your pivot table. Great. Keep in mind though that in general, the queries that Excel generates to the source are not as optimized as the Power BI queries. So when you use Power BI visuals, it will be more optimized and faster than Excel. And why is that? It's very simple. Power BI uses DAX, which is a newer programming language, newer query language than what Excel uses. Excel uses MDX, which is the older one, that is simply not as fast and not as optimized as DAX. So whenever you use Excel, it will generate MDX queries. We'll still be able to handle it, no problem, but we will be slower than when you use DAX queries. In general, that's the case. And of course, this feature is no exception. The same problem exists. Excel generates MDX, so your performance will be worse than when you went through Power BI directly. Also, especially some of the patterns, so some of the queries that Excel generates are non-wholesalable, so they seem to be referring to multiple data sources, so they won't get optimized. Although technically they could have been just wholesalable because they only refer to one single source. But if that happens, the MDX queries will not be optimized. So even if you are very careful about how you build relationship and how you build your visuals following all the best practices I just shared, if you use Excel, you will not benefit from the same performance benefits you will get if you did that in Power BI. So that's just something to keep in mind when you work with Excel with this feature. Now, remote measures is also a very interesting one. So remote measures basically means it's a calculation that has been predefined in the source that I connected to. So when you work with that, you don't know what's happening inside of the measure. There could be all sorts of things happening inside of the measure. And as a result of that, they're a black box. And there's a couple of things that don't work. So the second one here, the second bullet point here is when you use the all selected or all function, which is basically remove all filters from a table. So if I do all customers, whatever the filter has been set using a visual in Power BI will get removed, will not work in remote measures because we simply don't know what the measure definition really is and what the table filter definition really is. So they won't work if you use a calculated column in a composite model. So if you define a calculated column and say, what's the average sales for all customers? And you say that sales is in the remote model, that calculation will not work. That's just something to keep in mind. Then when you have measures that generate non-blank values, so always return a result that's never blank, it might have performance issues as well in non-wholesalable queries. So when it spans more than one data source, there will be potential performance issues for you as well. Now, the other thing is calculation group. This one is really exciting. First of all, if you use a calculation group, all formatting is lost. That's just a bug. We'll fix it. That's not a big deal. The other problem is the following. Let me explain what a calculation group is. A calculation group basically allows you to change the calculation on the fly. So you could say, I have sales amount, which is a calculation. It's a measure. Great. Now, in a calculation group, I could allow my users to say, do I want to see the actual sales amount? Do I want to see, for example, the year-to-date sales amount or the quarter-to-date sales amount or the month-to-date sales amount? My users could decide that when they look at the report. So they could see that sales amount, they could see all the charts, great, and then they can change it to year-to-date. And then they see all the charts update to that sales amount using a year-to-date calculation or a month-to-date or a quarter-to-date. So that way you can provide great flexibility on what people are actually looking at when they are using a report. Now, great. That's a calculation group. If you have a calculation group in that remote model, so the source you connected to, you might run into interesting results because if you don't know specifically if that calculation group will be applied. So the calculation group that changes from actual to year to date, for example, will only apply on wholesalable remote measures. So only on measures that have been defined in the source and are only dependent on that one source. That's where it gets applied. So if you look at the bottom here, I have a total sales measure definition in my local model. I have an internet sales, also a local measure. And I do total sales equals internet sales plus reseller sales. Reseller sales is a remote measure, which might be impacted by a calculation group, but you don't know necessarily, but it might be. Now, what will happen is internet sales is local, so your remote calculation group will not be applied. So as a result, your total sales is really weird, because if I set my calculation group to say year to date, the only thing that will change here is reseller sales. So now I have a total sales measure that takes an actual internet sales plus a year-to-date value, which is most probably not correct. You would have assumed that if you switch that calculation group to year-to-date, that also internet sales would have changed. It won't. It doesn't. It doesn't get impacted by the calculation group. So just be careful here. If you use calculation groups with this kind of feature, think about, wait, that calculation group only gets applied to remote measures if it's a remote calculation group, or only gets applied to local measures if it's a local calculation group. It won't cross the sources. Just keep that in mind, because if you just do this sum and go call it a day, these results will be really weird because you added an actual and a year-to-date value together, which doesn't make sense at all. Just something to keep in mind. Okay, and then the last one is when you work with more than one sources. So you have source group A and source group B, right? So you have two DirectQuery sources here. You can only currently filter, so build use an actual filter to filter one table in a source group. So source group A has calendar, source group B has budget and sales, right? That's on the top here. You can only use that calendar, that date table, for example, to filter either budget or sales. So you can say, what's my sales for 2020? But you cannot at the same time in the same query ask for what's the budget for 2020 using that same filter. You cannot do that. It's a limitation that we're working on resolving, but you can't do that. So that's just something to be aware of. The other thing at the bottom here, which is even more tricky, is source group C and D actually have sales and region in D and then customer in C. So what you might be wanting to do, you might be wanting to say, you know what, I'll build a relationship between region and customer. So now I know which regions has which customers. Great. Then I'll also build a relationship between customers and sales, because now I know what we sold to whom. And now I want to do, in each region, what is the total sales? So what I do, the only way to get from region to sales is via the source group C, right? You see that region is in the bottom in source group D. Then you exit source group D, you go to source group C in the query, it gets the customer, fine. And then it filters a table back into source group D. This is not allowed. It is like a triangle movement or whatever. You exit the source group, you go back in using the same query. That is not okay. We won't remove this limitation, by the way. That's not in the plan. In this case, that is just simply not allowed. We're not allowing you to do this. You will see errors. So in this case, what you should have done, should have said, you know what, region should probably have been part of source group C, because region is not a dimensional, it's not a fact. It's not related immediately to sales. It's only related to customer. So really, region should have been in C. If you did that, then there would have been no problem, because then region can filter customer, it's on the same source group, fine. And then customer can filter sales, which is just one source group filter across, which is also fine. You're not doing this weird movement. Alternatively, you could have moved customer into source group D, because then everything would have been in one source group again. So there is no issue. The moment you cross these two sources, more than one sources, and you do this like bidirectional movement of exiting the source group and then going back in using that relationship or using that filter, that is where the problem starts. So just keep this in mind whenever you work with this. You see issues, you see errors, that is basically what's happening here. Okay, so that will wrap it up for what I had prepared today. So just in summary, keep in mind this feature that we introduced in 2020 is still in preview. It is very powerful, but it has its challenges. It has its potential issues, pitfalls that you have to think about when you work with it. I gave you the most common ones. Set yourself up for success by following those best practices. They're best practices for a reason. Just, don't ignore them. And then keep in mind the special considerations like for Excel, calc groups, or cross-source group relationships that sometimes shoot you in the foot when you are not aware of them. Just something to keep in mind. Some resources for you if you want to read up more about this. The first link has all of the information you need about this specific preview, the ability to create a composite model based on Azure and other services or a Power BI dataset. So that's the preview that we talked about that is live since December 2020. Then the second link is the general composite model documentation that explains you everything you need to know about a composite model, including this, but also the others that exist. The best practices that I talked about today will eventually, once we solidify them, be added to these pages, so you can find them there as well for your reference. So with that, that's all I had. So if there's any questions, I'll be happy to answer them.
Very nice, very nice. The calculation group. What is actually the primary advantage to use it? I mean,
it is deduplication of DAX statements. So for example, if you have sales amount and you wanted to do a year to date over sales amount, you can add just a calculation. You could say add one more measure and say that's the year to date of sales amount. Fine. Now, if you wanted to do a month to date, you can add one more month to date of sales amount. Fine. Right? So that way you could build it. You don't need a calculation group. However, let's say people say, I wanted to do a year to date for sales amount, and I also want a year to date for cost, and I also want a year to date for profit, and I also want a year to date for number of support tickets. Suddenly, you'll find yourself creating multiple measures to calculate on the actuals, like profit, support tickets, number of customers. Fine. And then for each type of aggregation that people wanted, the year to date, you'll be creating another 4 measures, right? So let's say you have 4 source measures, you create another 4. And then people say, oh, I don't want year to date, I also want month to date. You create another 4. And if the people go like, oh, I want quarter to date, you create another 4. So suddenly you have 16 calculation definitions in your model, which is not bad. It's just not very easy to manage. Now, calculation groups can solve this. You can say, a calculation group, I just define year to date, month to date, and quarter to date, and it will just take whatever measure you put in. So it will just say, whatever measure you selected, you're currently working with, I will calculate the year to date over whatever you gave me. So now I only have the 4 measures that we had, sales, profit, cost, customer tickets, or whatever it was, right? And then I have one calculation group that defines actual, year to date, quarter to date, month to date. And then basically it's like a function. So whenever people say, I want to see year to date, whenever we do a sales amount calculation, then the calculation group will say, oh, I'll take the sales amount and calculate it as year to date and return that result. So basically now I have only one calculation group to manage and 4 measure definitions instead of 16 objects to manage. Now I have only 5. That's the difference.
We have a question in the chat. Do you have a time frame for when composite models will be moved to production? So to the make from preview to do so like public availability.
Yeah, I don't have a specific timeline that I can share here in this public audience, but we're getting very close. We're looking towards hopefully end of the year, on end of this calendar year. That's our goal. That's our planning so far. So then it has been in preview for just 2 years, a little under maybe, but that's around that time we should be okay. That's what we're targeting. If you use premium or premium per user workspaces, most of this feature is already available to you fully. So you can absolutely just use it. On pro workspaces, we still have a lot of work to do. So that's why we're not calling it general available yet. And I can also share the PowerPoint, no problem.
Thanks.
Just to answer the other question that was in the chat.
I was going to that. Guys, any question? You can just shoot or type it out.
I think somebody's typing.
That's it, yeah.
So does this calculation groups works on remote source as well? I mean, is it only on the local model?
It works on a remote. However, depending on how it's being defined, you need to be careful with what I showed you with like that combining things, right? So a calculation group that's in the remote model will only ever change what's in the remote model. So if I have a measure in the remote model and a calculation group there, the calculation group, if I change it, will only affect what is in the remote. It will never affect what is in your local model. So if I do a sum of two things, like a local measure and a remote measure, if I have a calculation group, that might actually not make sense.
Yeah. Okay.
But you can definitely use it. Just be careful. That's what I was trying to say.
Right.
There will be no error or whatever. You will not, it will not stop you from doing that. But yeah, it's just something to keep in mind when you work with this.
Another question, guys? So what's the current time there? It's still quite early for you, right?
Yep.
Okay, let's speed it up, and then I know you would like to start your day and do other things.
No worries.
Okay.
You have a bit of time, but yeah, sure. If there's no more questions, I'm happy to wrap it up.
Powerful. Yes, cool.
Okay. So thanks a lot for doing this. Thanks a lot for spending the time. Thanks a lot for having me. Thanks a lot for being part of the Microsoft community and Power BI specifically. And I'll share the slides, and you will probably publish on Meetup, I guess, somehow.
Yes.
And then
also I'll put it on, upload it to YouTube later. Yeah.
Okay, great.
It's a pleasure to have you. Thanks a lot.
No worries. You're welcome.
Enjoy your day.
See ya.
Bye-bye.
Bye.
Bye, guys. Ciao.